Thank you, everybody, for yet another awesome presentation for the XR enablement track today. I appreciate very many of you who are staying through many of these presentations. Again, I'm Louis Normandan, COO of Wild Capture, and for us at our company, we are very excited about digital human technology, and not just the implementation of digital humans themselves and the data streams that support them, but how they interact with the world around them. So in the next presentation, we're going to be really digging into the construction industry and how this relates to everything that supports larger environments that for us is very exciting. So I'd like to welcome to the stage Anneka Chand, the VDC manager of the Canadian Turner Construction Company, and Nathan Patton, product manager at Trimble.
All right. Good stuff. We've been told the big green button is the one we need, so I think we're good. Cool. Well, thank you guys so much for coming out today to hear what we have to say. We're really excited to share what we've been working on at Trimble and how we've partnered with our amazing customers like Anneka Turner Construction Company to get extended reality out into the real world and beyond that kind of lab experiment phase and out into real tangible environments and real industries, helping people to get their jobs done better. So today, we're going to take you through a little bit about what we do and how we've looked at bringing extended reality into the construction industry. So just to begin, just to introduce myself, I am a product manager at Trimble. If you don't know who Trimble is, we are a large industrial technology company, and I focus specifically on buildings construction technology. How do we bridge the gap between the digital and physical? How do we connect the people along the way? And ultimately, how do we try and transform the way the world works? That's our marketing slogan, as it were. And I'll let Anneka introduce herself a little bit as well.
Hi, everyone. My name's Anneka Chand. I'm from Turner Construction Company. Turner's a pretty large general contractor. So architects and engineers design, and we go and build. My background is architectural. I'm from the UK. Since moving to Canada about 5 years ago, I decided to move from, I don't know which is the dark side, design or construction, but I'm now in construction. And I work as a virtual design and construction manager. So we deal with all things virtual. We try and bridge the gap between the Stone Ages and the new world and try and implement technologies that are going to make our life easier and let us build more accurately.
Yeah, amazing. And so, like Anneka said, she comes from the industry. I'm in the technology space, and what we've really done over the past year is try and blend those two worlds together and do a little bit more in situ, in-field testing, and really understand how we can put these technologies through their paces. At the end of the day, they're only going to work if they actually work in those real environments, in those real workflows. So it's been amazing to work with Anneka and Turner on this. So just to start, to set the scene, I feel like it might be good to walk us all through what a typical construction process looks like today. We go through this kind of waterfall process that really has not changed since early Egyptian days. Right? Construction has not changed that much. The tools changed a little bit, but the process has largely remained the same. We start with this designer, an architect, an engineer who works with the owner to design out and model out what their desires might be, and thinking about all of those crazy, unique concepts that you've seen from crazy architectural design firms and stuff like that. And we produce typically some type of model or some type of plan. Right? And it's maybe not so much attached to reality, but really just attached to this vision. And then we take that to the detailers and the designers and the engineers to really go through this process of converting that vision into something that can be physically constructed. And we parcel out all of the building components, the electrical, the HVAC, the ductwork, the structural, the concrete. Every little nut and bolt that goes into that building needs to be considered, scheduled, budgeted, considered, and coordinated in order to make sure that all of those various designs and systems fit together into one design. And so we go through this coordination process throughout construction, making sure that things are fitting together. And at some point, we have to go and translate that into the physical environment to try and execute, to try and build on those designs, right? And so in that process, we kind of get this waterfalling cycle where we go from ideation and design into coordination into execution. And somewhere along that process is like the telephone game, where we have one thing that goes to the next person, and they have an idea of what that means, and that goes to the next person and to the next person. And ultimately, it lands in the field where we don't really have a lot of those technologies. We don't have easy access to a desktop computer where we're on the 20th story of a brand new high-rise. We have paper plans. So we end up printing thousands of pieces of paper for every construction site, for every revision of the model. And guess what? If someone in the office makes a new revision, all of that needs to be reprinted out and readjusted, re-looked at. And so this is how we're tracking changes in the field. Not with those fancy 3D models, not with all of that intricate design detail. Typically, it ends up in a process like this where we're using pen and paper and highlighters to mark out those changes and identify issues. What does that add up to? Some pretty big macro problems, right? So 96% of all data in the construction industry goes unused. It goes wasted. It goes siloed on an iPad with a foreman who leaves it in the back of his truck all day and forgets about it. 96% of all data in construction goes wasted. And what does that mean when you don't have data to make your decisions and you don't have clear paths of communication to get people on the same page? Well, you end up redoing a lot of stuff that you shouldn't have to redo. You end up building a wall just to knock it all down and move it over by a foot. Or you design a system and implement it and install it only to realize it doesn't actually fit that area because there's an unknown, change in somebody else's design that they didn't tell you about. And so all of that adds up to this massive amount of rework that costs the United States alone $280 billion a year. That's just in the United States. And what's more is that all of those materials that we're wasting, the drywall, the concrete, the steel, all of that stuff just gets thrown out. And all of the carbon that goes into creating those materials, the carbon that gets emitted in installing those materials, that adds up to 3% of global emissions worldwide. That's just from the United States. That is a massive, massive macroeconomic scale that these miscommunications and this archaic process has on our world, on our economy, on everything. So at Trimble, we like to try and think, how do we connect the digital and physical? And more importantly, how do we connect the people involved in construction in order to transform the way that they're working and solve some of those problems? And so in my role, I've spent a lot of time on job sites in the last several years. In fact, I have my steel-toed boots with me today because I was on a job site yesterday, and I promise they're not a prop. They're just with me because I have to go right after this. And what we've learned is that there's a lot of ways that we need to be addressing these problems. So first and foremost, we need to connect the people in construction. And we need to make it easier to catch those mistakes throughout the construction process, not only after they've been made. We need to be able to democratize access to data. We need to get models and designs and information into more people's hands so that we can all be making better decisions. We need to increase the communication and the connection between those in the field, those in your manufacturing fabrication shop, and those in the office so that we're all talking to one another, understanding what's happening. And ultimately, there's a labor shortage around the world in literally every industry. And until AI comes to take all of our jobs, there's always going to be people that need to do the work. But we need to make our tools so easy that anyone can come in and use them. Or else, it doesn't matter how good your system is, how good your platform is, if no one can figure out how to use it. So with all of that in mind, we kind of had this idea. What if we could combine the visual, immersive, intuitive context of mixed reality with the tools that are really accurate and really beneficial in construction already today? So this image here on the right is a total station. I don't know how familiar any of you are with a total station, but it's a very fancy laser pointer that knows exactly where everything in your design needs to go in the real world. And the construction industry has been using this for decades already, so it's nothing new. But the concept of being able to visualize that data in an immersive mixed reality environment, that was something different. And we thought that if we could bridge those two together, we'd be able to solve some of these problems. So last year, we released FieldLink MR, which was this tool to connect exactly that. Leveraging our partnership with Microsoft and the HoloLens 2, we have the Trimble XR10, which is this hard hat enabled HoloLens device you see in the top left, pairing it with the total station to create a fully immersive experience, giving complete control of that really accurate positioning system to the end user in the field. And let's see if this plays automatically. Maybe, maybe not. We'll give it a second or two here. But last year we came to AWE actually, and were named finalists for an Augie Award for this technology, for this tool that combined that massive immersive experience. And what this really allowed people in the field to go and do was visualize all that data and no longer do this guesswork of seeing a two-dimensional tablet in front of them versus the design data that's in their head and this mental model. It allowed people to get up to speed a lot faster. And so as I get told the signal that my video is not working, we'll just cut off into this because GIFs are just as good as videos. So looking back at those ways that we've kind of identified, how do we need to solve these issues in construction? Well, first and foremost, we need to be able to visualize the design and understand, does this fit on the job site? And so leveraging mixed reality now allows people in the field who are on the job site every day to see the design work in context. And they can catch mistakes. So this is an example of a high-rise going up in Miami where a colleague of mine, Andreas, is able to see the underground piping before it's been constructed. And he can tell, is it going to interfere with the laydown area? Is it going to interfere with other ongoing construction? Get ahead of any rework, right? And so this is another example. How are we going to democratize access? Well, now we're getting it into the hands of more people who are on the job site every day. It's not just siloed in the office, but it's accessible to more people. So now we're able to get more people making data-driven decisions in the field using that design. We connect the office and the field through our web platform, which allows everyone to be speaking the same language. The same model that you're designing and working with in the office is the exact same data that you're using in the field through our Trimble Connect web platform, which is what you're seeing here. And the next step beyond that, we automated the process of capturing data and sending it back into the office. So those that are in the office can see the progress being made, which is what we're seeing here, these green dots. Those are the points that I laid out with that total station. And I found them by using mixed reality and seeing it much more intuitively. Right? Green means good, red means bad. So now the people in the office can see the exact progress that's been made and see the quality of the work that's been done in the field. So further connecting those two places together. And finally, we met the customer where they were, or at least we're trying to. I'm sure all of you at this conference are aware that hand gestures in mixed reality are great to an extent, but they can be pretty buggy. They can not work when you're wearing gloves or when you have long sleeves on or when you're out in the field in minus 40 degrees Celsius and it's really cold out. You don't want to be messing around with your hand gestures. So we built this whole app to work, yes, with the hands, but also with the eyes and the head. You just simply have to look at a button and it will turn on just like that. You can also use your voice. Use voice commands on the construction site or in the shop so you can just say, measure, and it'll work. So really trying to make this experience as intuitive and engaging as possible. But one thing I did learn, thanks to Anneka, is that different accents have different implications with the voice command. So what we really needed to go and do was partner with somebody who was actually in the field doing this work every single day and see if it could actually work. And so that's where Anneka and Turner Construction came in. I'll let you take over.
Green button, right?
You got it.
Okay, so we worked together and we went through a series of testing projects across Turner. I'm based in the Vancouver office, however, we work closely with our Seattle office too. So this is a Seattle aquarium. It's pretty iconic, it's in downtown, just along the waterfront. It's a huge project. There's a reconstruction and redevelopment of the roadways. It's going to connect to the Pike Place Market. And Turner Construction are responsible for the Ocean Pavilion. It's a huge tank. It's going to contain 325,000 gallons of water. So it's structurally an interesting and challenging job. So the huge problem we have is, okay, we have this main tank design. How are we going to construct this? And how are we going to communicate the design to the field to make it constructible? And just looking at the images there, you can see the complexity of the form. And we can see that this is going to be very tricky for somebody to construct on site accurately and reliably. So what we want to do is simplify it as much as possible. Tanner VDC actually created a series of models from safety and logistics to this model you're seeing here is the rebar design. And just to give you an idea, the rebar on this project is 3 times that of a typical 50-story commercial building. So it's a lot of rebar and clearly not a standard rectangle form either. It's curvaceous. So we have all these series of models, but again, how do we get people to actually view those models on site itself? Because we already struggle with that problem. So what we did is we worked with our self-perform operations group, known as the SPO, Turner SPO, and we produced a series of 2D drawings, 2D details, which people can view, but also generated from the model detailed drawings which contain isometric views and measurements to grid lines. We made it as easy as possible that we possibly could in order to communicate the design, primarily, firstly, in 2D, but generated from the 3D model. Because we find people in the field are still not comfortable with pulling up a 3D model and going through it unless they're calling one of our team members to come over and do it for them. Every single piece of the structure was tagged, and so it was almost like what you get out of IKEA with instructions on how to go. But it's still not enough. How can we trust that people are still looking at the right information? It's accurate, it's reliable, it's the latest piece of information. And that's a huge challenge that we have. You can see from these drawings, they're quite complicated, but also easy to understand for somebody who knows how to read drawings. But when we're out in the field, we want to then get the model into the field, and this is where we use FieldLink Office, in which the model was brought in to FieldLink Office. We're setting control points for model-based layout. And so the idea is that this can be pulled up on the tablet in the field. And here you've got a picture of the RTS, Robotic Total Station, with the tablet and people using the model. But wouldn't it be cool if you just eliminate the model completely and just in a 2D form like this, where it's on a tablet, and actually have it blown up, augmented reality in site context? That way we're seeing the intended design, and it's easy for somebody to put on a headset and off you go. So that was kind of the problem that we wanted to test on several of our projects. The aquarium is a highly complex project, but just to explain this further, I'm just going to simplify it a bit. So we took a basic, this is our SPO warehouse that we have in Burnaby in British Columbia, just outside of Vancouver. And it's a very, very simple model. It's so simple that we actually got our superintendent to build this model for us. It's his space, so he was like all geared up to go with it. So we used SketchUp, produced a very simple model, uploaded it into Trimble Connect, which is the online cloud-based platform to share the model information. We brought it into FieldLink on the tablet, and we created some control points. Those same control points we measured out physically on site as well. And this is Preston, so he's wearing the XR10, the HoloLens headset there, and he's going to bring the model into the headset and then start to measure these control points. So what you're seeing there is how the model came in through the headset. And then once we've measured, there it is, blown up. And that's when we had this aha moment, like, okay, we're actually seeing the walls and everything in the reality of the space, so within site context. And the purpose of this was just some testing on a very simple project, but also he wanted to determine some items like racking and where are we going to have some openings and that type of thing, shelving. So we could put more detail into the model and open that up, and to see it within the space was just extremely valuable. We also tested one of our other SPO members, who's just a simple carpenter and also a laborer as well, who just came in one day. He was just around stacking some gear in the space, and we were like, oh, do you want to just check out this and put it on? Just to see, okay, can just anybody who's not really savvy with technology, can they just put the headset on and go? The short answer is yes. The long answer is there are still a few teething problems we found with gear speaking to each other and getting the setup right. So we found it took a little bit of time for people to set up. So that would be myself and Preston were working together to kind of set up the gear and get it all loaded in, get the model in, up and open. But once it was on, it was fantastic, and people were so enthusiastic about using this. So some of the outcomes are, it definitely improved communication because we tested it on several projects, and one of the projects we laid out some electrical boxes, and we found that somebody who can't necessarily interpret drawings was able to put this on and be able to kind of shoot points and lay out. So it wasn't quite instant, but this is what we want. We want a pot noodle approach. We do want the out-of-the-box solution, just very basic, put a sachet in, press a button, and there you go, it's done. That's what we would really like. Like I say, we're still not quite there yet because I think some of the gear talking to each other has been a problem each time. However, it did de-silo the site and office as well. So on the aquarium, we were able to measure spaces, have them constructed in site using a model-based layout approach, and then have the data feedback to the office so we can check, are you actually building to the model? And for a job like the aquarium, it's so important just because of the sheer complexity of it, so important that every step of that project was constructed as per the coordinated model. The modeling process and the adoption of that process has been so critical on that project compared to other projects. It's allowed for visualization of the data. People tend to be a little siloed in their own area, so we have the mechanical trades may only look at the mechanical drawings when they're out on site constructing versus electrical or structural and so forth. So bringing all this information in together was highly beneficial. One thing we had to do, though, was maybe cut down some of the model areas so that the data is more manageable in terms of file sizes and loading and so on. But if those models are managed correctly and a bit more with an OCD approach, then there's no confusion over the information. You know which information is, which part of the model is, which area it's the latest. And that kind of needs to be policed a little bit in order to get the best outcome and cause less confusion. And then improving quality, that came as a byproduct because you've got this incredibly accurate measuring tool compared to traditional survey methods. And we're vetting that with this de-siloing of this two-way communication between the site and office. So having that back and forth actually brought the two teams together because there still is a bit of a gap with information being communicated both ways. On a project level, it's great potential to educate and train teams because you bring in them awareness of the project. The more eyes on the model, the better. Unfortunately, people are still stuck at the point of they're happy to get the latest iPhone, but they don't want to open up a model. They don't want to open up a new software or overcome this challenge they have with being able to run software. So we want to make it as easy as possible, and that's why we like the AR approach. But secondly, for example, the SPO warehouse, a very simple project, we want to use it as a training base to actually teach people how to do model-based layout in the first place. So if we can teach layout using the headsets and this model-based approach, we feel we can get better quality output from new members who join or existing members that we have on our teams. A couple of other feedback we had at the time was probably, we like big buttons. Big buttons, we need things that we're able to see easily in our field of views. For example, there were windows that might pop up out somewhere and we kind of had to search around to find them. What we thought would be a great suggestion is having prompts. So maybe we could customize those prompts. So this technology can apply to multiple industries, but for construction and layout, we might want prompts that tell the user kind of how to do something. So if we're using it for training, now you need to go and shoot this point. Now you need to go and click here and maybe have like arrows or something that makes it that much more simpler for people to adopt the technology more easily without someone in the background telling them what to do. But what we found extremely useful was Microsoft Teams and being able to show people on the screen what to do at the same time as testing this technology, so we could help troubleshoot.
Awesome.
Yeah.
Yeah, so just to close out here and get into some questions for sure, we wanted to think about how do we take these learnings from working with Anneka and Turner Construction and think about the future of those technologies, right? So this kind of goes to what she's saying of having these guided prompts and things. What if you only needed to press one button to actually learn and do your work, right? What if you put this hard hat on and you pressed go and you were given this list of all the stuff you need to go and do and you're able to just simply get to work, right? And what if you could survey the metaverse, and not to use that buzzword, but really what if you could take the data that you're capturing today, save that data so that the next person that comes to the job site that isn't using that total station or is just using their phone, we've saved that data back in the cloud for them so that they're seeing the model aligned and perfectly done with all that accuracy that you've kind of gone and portrayed, right? So how do we share those combined experiences and get more people talking on the same level, talking with the same information? So that's kind of what we're seeing as we're pushing forward, is to address all of the learnings that we've had with Anneka and Turner and continue to provide new tools for getting people on the same page, leveraging this technology. So really appreciate all of you being here. Love to open it up for questions. Yep, right here.
We got a microphone coming to you.
Oh, I think he may have a mic for you.
There you go, brother. Thank you. Michael Schroeder with Gallerist. So I think it's amazing what you're able to do at Turner, because you have your Turner home office, which is doing the design and modeling and stuff, and getting it with the construction site. Now, you coming from a world of architecture, how is the communication happening with the architect and the contractor when everything has to be flattened for the contract to paper?
So in this application, we're building from the vector drawings. So the aquarium was a much more collaborative approach, where there was so many flags that design flags that we picked up, where the architects couldn't get out of it. They had to be in those conversations in order to make decisions happen. But ordinarily, it's tricky to get the architects to engage with us. And that's a huge problem. And there is this traditional paperwork route, and there's so many RFIs, and it's a constant challenge of like, okay, we're going for a model approach, and if you're all agreeing to this BIM implementation plan, then that's now contractual. That okay, we're agreeing to go through a coordinated process. Typically, architects shy away from it, so they're just like, okay, you guys are constructing, you guys coordinate and carry on, and anything that is large enough to allow for a change order or an RFI that needs to be recorded that way, we'll use technology and things to record those as we go along.
Yeah, and I think to piggyback on that, we showed in that first slide this typical construction narrative. I think if we really want to solve the deeper problems, we need to look at it from that perspective, that huge narrative. How do we change the way contracts are established? How do we change the way owners look at this whole process to tell architects and engineers and everybody involved to get on the same page, right? So I think that's probably the higher level order thing that needs to change. But today, getting people in the room and sharing those details is kind of what we're trying to do as much as we can from a technology perspective. Yeah, for sure. Is there another question?
Yeah, no, thanks for your very detailed presentation. So Kingsley from My Home AR. So my question is twofold. So first is, what do you think is causing the hesitancy in adoption of XR tech in the construction industry, whether industrial, commercial, or even residential? Because this has been out for some time, right, with BIM 360.
Yeah.
But it just seems like it's very slow adoption in all those different laterals. And then the second question is, where do you see generative AI helping to accelerate some of the development and innovation, maybe in transforming models from 2D to 3D? What do you see in that space? And what is Trimble doing as well?
Yeah, for sure. I'll take a first pass and I'll let you get your thoughts in as well. But so on that first part about adoption of the technology and those types of things, I think what we've seen from our side is just you have to have the right experience and the right tools, and it can't disrupt the workflow too much, right? It needs to fit in with what people are doing. And today we haven't seen those technologies really fit that workflow and just be an extension of what you're doing. There's too much disruption still. And as a whole, I'd say there's been this lack of ability to provide really quality UX around such a new space like this. And it makes it that much harder to use, right? So when I was talking about the head gaze and the eye gaze and the speech, in order to control your application, right? Those were all things that we're not always doing out in the construction field, and we're not out on the job sites testing those technologies. So I definitely think UX is a big part of it, and just fitting the right workflow. The other side is that as a whole, the construction industry doesn't like to adopt technologies. XR is nothing different, but we talk about total stations being adopted. Those things have been around for 100 years, and some teams are still using paper plans and tape measures and plumb bobs. So there's just an element of this is how I've always done it, and that's the path to go forward. So there's a handful of just societal, like systemic problems in that adoption, but then there's the onus is on us as the technology provider to make better experiences and just give you that value. So it's a bit of a 50-50 there, I'd say. And to your second point around generative AI and what we're doing at Trimble, we've had an AI team for a decade already, if not more, that's been working on how do we leverage those tools, those AI, ML models, to automate really medial, repetitive tasks that people are doing, like if you're familiar with point clouds or any of that type of data, it's massive data sets, and you've got these people manually going through to clean up the data and design off of it and extract insights. Nobody wants a point cloud. They want the end goal, which is it good or is it bad? Is this much progress? Or here's the model that I created from it. So we're leveraging AI and ML to automate those things, to get you from point A to point B as fast as possible without that manual intervention along the way. So I really see AI in this world being a bridge to get you from what you have to what you want and what you need, and cut out all the medium stuff in the middle of trying to figure out the right button to press after this button to press after that, and kind of just help make that whole experience easier and more streamlined. So that's what I'd say our focus is, just how do we meet the construction industry where they are, but bring them into that new world of this new technology. So.
Yeah, and just to add, so our supers, one issue they had was they can't wear the headset for longer, for too long. So they kind of need a break, but they saw the possibilities, like, okay, what if we just walked around and were able to install things, use some other robots and things to just manually, say, put in some anchors, that type of thing. So I think some of them are thinking along the lines of where could this lead us to, but the physical helmet, wearing it for a long time is quite uncomfortable. The second thing is what we had was, what if, okay, forget the 3D model. What if we can just overlay 2D drawings? Because that's going to bring so much value as it is. What if we had elevations, but some of our laborers don't know, some of them don't know like how to understand drawings as well as others. So how can we actually just make it easy for them and already have those 2Ds overlaid? And that's something we could do pretty easily using the technology that we have today. So that was an easy one. So we're trying to get them to use more model-based approach, but sometimes it's very easy to fall back on what they're comfortable with, and it's hard, but hopefully we get there.
Yeah, but even introducing those 2D workflows kind of gives them that step into this
forward.
New world, and now there's more value in 3D and stuff. So I'd say it's really about the experience at the end of the day. The physical hardware experience as well as the software experience that you're going through to meet those field users at their level, right? Yeah. Cool. All right, well, thank you all so much for joining us today. Really appreciate you all taking the time, and great questions.
Thank you.